Hello, today we will learn how to compute normal distribution probability values and its inverse values respectively. And we do not use the standard normal distribution table. For standard normal distribution table, we have to convert the general random variable x is equal to uh, z. Z is a standard normal distribution. Z is equal to x minus mu divided by sigma, this form. So actually this is a very popular and important formula. Instead we just use norm.dist function and the norm.inf function. Norm.dist and norm.inf function. First of all, read the problem, and we have a mean value and a standard deviation. Mean value is 100, standard deviation is 10. Then we can write this way: x, random variable x, follows normal distribution, n stands for normal, and we have mu and sigma square. Then for this problem, we can write x follows normal distribution, mean is 100, sigma is 10, but we have to use a square form. So please remember this notation very clearly. And now we have a couple of questions. Uh, question one. Question one, we have a probability x is less than 80. If you have a normal distribution problem question, first of all, you have to write this equation mathematical form first, and then second, for normal distribution you have to draw a graph like this. If you have this normal distribution information, and this center is mean value 100, and then now you have to find this number, the given number 80. So 80, and this is actually less than 80, then you have to shadow this area. This area is our probability. This value is our probability. So we have to use this one. Generally, we can compute z is x minus mu divided by sigma. Then x is 80, mu is 100, and sigma is 10. And then you can find the negative 2 as a z-score, and then you can read z-score table, right? But however, for today, we do not use z-table, so I just use Excel function directly here. I just rewrite problem x is less than 80. Then for this case we just use norm.dist. So first of all you have to type equal and the norm.dist, and you can find the four different parameter: x and the mean, standard deviation, and the cumulative. So x number, for this case x number is 80, mean value is 100, this mu is given, and standard deviation is 10, and the cumulative, this must be cumulative most time for our class, so please use 1 for the last parameter. Then we have this probability. This probability back in our graph, this probability is what? This area is 0.0227. This area is actually this number. So you can solve second question. Second question is a similar one. So second question also you can write the equation problem. Second question, P is x is less than 120. Then typically you can compute z-score. Z-score is actually x minus mu divided by sigma. Then what is x number for this problem? X number 120. What is mu? 100. Sigma is 10. Then you have 2. So you have 2 of normal score. Then you can find the standard table, and then you can find probability value. But for today we do not use normal table, so that's why we just use normal Excel function. For again, this case we have 100. You have, first of all, you have to draw a graph 100 and this number 120, and we can shade this area. This is actually left side area. Then now we can use Excel again. Excel, I just type problem again, but left column A, this is just nominal expression. Column B is our actual function, so you can type norm.dist, and the x is for this problem 120. What is mean? Mean value is 100. What is standard deviation? 10. And cumulative is always 1. So you can type this one. This problem is point. This problem is 0.9772. This area is actually our probability value. And now let's try to solve problem 3. Problem 3 is probability of x is greater than 90. So actually norm.dist function basically will compute the left sided area, but for this problem 3, px greater than 90, if you draw graph, this is 100, 90 is here, so you can shade this right side area. For right side area, you cannot use norm.dist function directly, because norm.dist function is always about left side area. Then you have to rewrite this problem. We have to know the all area is 1, so that means 1 minus the other direction is our original question. Then you have to write this way: P is x is greater than 90. For this case, we cannot use norm.dist function directly, so you have to use x is less than 90. So you have to solve not first expression, second expression. Then you can type equal, and the first of all 1 minus probability is, which is norm.dist, and what is x number? This number is 90. Mean value is 100. What is standard deviation? 10. What is cumulative? Cumulative is 1, true. So we have this one. So back to our curve. This problem is 0.8413. And we can keep going. And question number 4. Question number 4. This is also similar. P is x is greater than 110. Then this again, you can draw a graph like this, and the center is 100 and right side number 110. And this question is graded area, right? Right side area. Draw graph first all the time. Then you have 1 minus x less than 110. So now you can use Excel function. Again, our original question, x is greater than 110, which is 1 minus probably x is less than. So now we can use less than function. It's equal 1 minus norm.dist, and the x number is 110. Mean value is 100, standard deviation is 10, and the cumulative is 1. So actually for this case, we know this problem number. Back to our problem. So we have 100 mean, and the standard deviation is 10. So we have this information. That's why I wrote x follows normal distribution n 100, 10 square, right? So we have this information, so that's why in our Excel function I put 110 repeatedly. So back to our problem. Question 5. This is a little bit different, but previous two types of question we have only one-sided area, but problem 5 we have an inable expression. So for inable expression we have to draw a graph. So question number 5, probability 78 greater than x is less than 115, then you can draw graph like this, and the center is 100, and this left side number 75, right side number is 115, and shade this enable. So this enable is actually 115 all the way up to 115, and we have this one, this 780. So if you get all the way up to left side number, all the way up to this graph minus this graph, you have to consider all left side area, and we subtract this left side area, then we have this one. So that means this inable equation we have to use x is less than 115 minus px is less than 70. So actually we have two left side area, right? So then for this problem, for question 5, so we can write this expression again, and this is actually x is less than 115 minus px is less than 78. So we have to solve this problem. To solve this problem, I have to use norm.dist. So first x number 115, and second 100, mean is 100 for this problem, standard deviation is 10 and 1, and minus second one norm.dist, and the 78 comma mean 100 and standard deviation is 10 and comma 1. So you can type this one, norm.dist first 115 minus norm.dist of 78, and we have this probability. So actually our for this probability is 0.919. I skip question 6, but we will solve question 7 and 9. For 7, we have a top 10%. Then again for this problem, you can draw graph again. Top 10% is this one. So we have top 10% area. But for normal distribution case, we have to take into account all the time, always left side area. What is left side area? This probability is 0.9. How? 1 minus 10%. 1 minus 0.1, which is 0.9. So you can use this probability, I mean 90 percentile number, not 10%, for question 7, top 10% case. We can use norm.dist, not dist, norm.in function. Norm.in means we want to get inverse number. Inverse is opposite direction, right? So previous problems we have x numbers, then we compute p-value, probability value. But now we have a probability number and we want to get x number. That's norm.inverse. So what is probability for this case? Not 10%, you have to use 0.9%. What does it mean? 10 and 100 mean 10 standard deviation, and 120. For back to our graph, this center is 100. This point is 112.81, which is 90 percentile or top 10%, right? And finally, so question A is low 4%. Low 4% means you can draw a graph like this. Low 4% is this one. This area is 0.4. For this case, low 4% case, we can use this number directly because this is a left-sided area. So we will use this one for our normal function, low 4%. Then we can use norm.in function directly. This probably is 0.04 and the mean 100, standard deviation 10. So for this norm.in function case, we don't need to put cumulative option because norm.in function is basically, it's all about cumulative. So that's why we don't need to add cumulative parameters. So this is 82. Then how can you interpret this one? So this is the center is 100 and this number is 82.49. So if you have this number, then that is your low 4%. This should be 0.04, sorry. Excel or 0.04, right? So please practice this our class example, then you should get used to this kind of a norm.inverse, norm.dist function.